Hi everyone, so in the previous video we saw how we can improve the controller of our system by simply adding a feed-forward term. And when it comes to evaluating a system control performance, one would say that this controller is better than the other because it has a better error tracking profile. And other would say, but this controller is better because it minimizes the power consumption of my model. And in fact, both are correct. When it comes to evaluating or optimizing a controller, we must also define the criteria or the aspects that we are using in order to evaluate the performance of the controller. And in fact, we can define analytically these two aspects via what we call a cost function. And usually when we want to optimize a controller, after defining the aspects that we want to consider when optimizing a system performance, we have to minimize this cost function for this particular controller. So this cost function may be calculated. Let's consider that this cost function is called J. So J is equal to integral to the error multiplied by a matrix Q multiplied by error transpose plus U, which is a control input, multiplied by R multiplied by U t dt. And in fact, if you want to optimize the controller in order to have or to get the best error tracking performance, what you should do is that you should put your R, let's consider that Q and R are scalars, so you put your R is equal to 0 and you put your Q is equal to 1, and then you can say that the controller that in simulation will record the minimum J will be my optimized controller. If you want to do the controller which optimizes the system energy consumption, you will put your Q is equal to 0 and your R is equal to 1. So when the error goes faster to 0, the J will become much lower. So let's try this in our case. We want to build our cost function right here. So first what we need is to get or to define the error, and then to define the weights that we are going to give to the error and to the control input, and we need to take into account the control input. So first let's take the error from here. So this will be my theta error in this case, because I'm following only a set point theta. I'll put it right here, and then I will get also my control input U. Then I will put it right here. Then I need to add the weights that I'm using. So the first weight will be my error tracking weight that I'm using to evaluate the system performance, and then I will take another one and I will call it the power weight. So this will be error tracking cost function, and the other would be my power consumption cost function. Next, what I need to do is to calculate these two terms, the two profiles. So I will take a product right here. So I multiply the error by the weight. Then I will multiply all of this by the error. Next, I need to do the same for my energy consumption, and then what I need to do is to add these two terms together. So I'll put an add right here, and what will I get finally? It's my total cost function, and I also need to add an integrator to finish calculating my cost function. Next, I will try to do some simulation to show you how the total cost function is calculated. So first, I have prepared the new application with a new tab called optimizing. So in this tab, when I click on this button, I will take all the value that are selected right here, and then I will run a simulation in order to visualize the cost function that I will be getting. So the first simulation that we are going to say that, okay, I will need to evaluate my controller only by considering the error tracking profile, and then I can launch a simulation right here. So what we will get finally is a cost function related to the error tracking performance, and then as you can see, it's a very low value of order 10 to power minus 2. Next, if you want to evaluate the system performance considering only the power consumption, you need to put the weight of the error tracking equal to 0 and the weight for the power cost function equal to 1, and then you can launch another simulation right here, and then you will see that they are both totally different. So as you can see here, we have a value of about 30, and if we want to consider both aspects in our simulation, we just need to put both to 1, and then I can run another simulation, and I will see that I will get my final cost function of my system. In the next video, we're going to see how we can use these two aspects, or one of these two aspects, in order to optimize the system performance using the cost function that we are getting from each simulation, and by running multiple simulations using the parametric sweep that we have seen in the previous video. We will run multiple simulations, and then we will select the controller that's recording the minimum value of the cost function that we are considering when we are doing our simulation. And again, I have added the model IT optimized and the application containing the new tab in the GitHub repository. So I invite you to go to the link. I'll put the link in the description, and then you can download the code right here and try it out yourself. And if you like this video, please don't forget to subscribe to my channel, and see you next time.